Today, half the global population consumes rice, a single grain providing 20% of all human calories.
For millennia, empires rose and civilizations organized around this single grain.
Governments, religions, and calendars were organized around the planting and harvesting of rice. Early civilizations organized their lives around this crop, unaware of its profound impact on human history. This tiny seed, pulled from a Chinese swamp, shaped more human lives than any other food. 9,000 years ago, the lower Yangtze River Valley was a marshland. Tiny edible wild rice seeds grew there. Flat, wet marshlands in eastern China were scattered with clumps of wild grass, bearing tiny edible seeds. This scraggly plant, Oryza rufipogon, was the ancestor of modern rice, often overlooked today.
Ancient people discovered these seeds could be collected, stored, and eaten later. Storing food was everything. Early rice cultivation evidence was found at China's Shangshan site.
Archaeologists found 10,000-year-old rice grains at the Shangshan site, showing clear human selection. Ancient grains were slightly larger with thinner husks, indicating early human selection. Subtle differences reveal extraordinary human selection. Farmers chose plants, shaping rice into something useful.
Generation after generation, farmers selected plants, turning a swamp weed into a staple crop.
Domestication was a slow, generational process. Thousands of farmers made quiet choices, transforming the species. Farmers kept bigger seeds, planted in wet soil. They watched, repeated, and the rice plants changed.
Rice plants grew taller, grains plumper, husks loosened, and seeds stopped shattering before harvest.
Wild rice shatters when ripe. Domesticated rice holds its grains, making harvesting much easier. This single trait transformed rice from wild food to a civilization-building crop, changing communities. Rice farming allowed settlement. Permanent villages appeared along the Yangtze and its tributaries. Larger settlements with communal storage emerged. Reliable grain supplies led to population growth. Stored rice prevented starvation. Rice cultivating communities gained an edge, becoming more numerous and organized. Rice farmers won, but growing rice in quantity required massive water management, unlike other grains. Domesticated rice needed standing water. Ancient Chinese farmers built paddy fields, defining their civilization. Farmers dug channels and built levees to control water, flooding, and draining fields. Staggering engineering, landscapes reshaped by hand-created aquatic environments for rice. The story takes an unexpected turn.
Paddy systems created food surplus, fundamentally changing civilization. This surplus transformed small villages.
Surplus grain was stored, traded, or taxed. Taxation of rice became crucial for ancient Chinese rulers.
Rice became imperial finance. The state controlled water, which controlled rice, which controlled the people. Farmers paid taxes in grain, soldiers ate grain. Rice fueled massive imperial construction projects and armies.
Paddy calories enabled massive construction and governance, thousands of years before modern economics existed.
Control of rice fields meant control of everything, a truth explicit during China's Han Dynasty. The Han government maintained vast granaries, using rice reserves to stabilize prices and prevent famine. During failed harvests, the state released grain to prevent starvation and uprisings. An early managed economy. Centuries later, the Grand Canal was built. It transported rice from southern provinces to northern centers.
The Grand Canal, over 1,000 miles, primarily carried rice. Cultivation then spread to Southeast Asia.
Southeast Asia's climate was ideal. Farmers adapted Chinese techniques, building elaborate terraced systems. Farmers developed double and triple cropping systems,
utilizing monsoon rains. Productivity was extraordinary.
Rice spread to India 4,000 years ago, reaching the Ganges. It transformed regions like China. Productive rice lands fostered population centers, kingdoms, and trade. Rice became cultural identity.
Rice arrived in Japan 3,000 years ago, fundamentally restructuring society through wet rice farming. Before rice, Japan had hunters/gatherers. After rice, farmers and hierarchies emerged, shaping Japan. In feudal Japan, rice was money. Samurai wealth was measured in koku, a yearly rice unit. Koku measured a domain's ability to sustain people and raise samurai. Land and taxes were rice-centric. Feudal economy revolved around the rice harvest. Korea followed a similar pattern 3,000 years ago. Rice became central to Korean life. Farmers developed sophisticated irrigation for hillside paddies. In many Asian cultures, rice became sacred. Offerings were placed at temples and shrines. Rice wine brewed for ceremonies. A rice goddess worshipped. Farmers believed rice had a soul. Rice cultivation created astonishing landscapes. The Ifugao carved thousands of terraced paddies into mountain slopes. These 2,000-year-old rice terraces are agricultural engineering feats found across Asia. Terrace systems required generations of labor. Communities organized social structures around shared water management. Asia and rice were stable. But European traders in the 1500s changed rice's trajectory forever. Portuguese and Dutch traders recognized rice's value. They established colonial control and trade. British dominated rice in Burma and India for profit. The most brutal chapter, the American South. English colonists found Carolina marshes resembled West Africa. West African expertise made Carolina rice possible.
Enslaved West Africans brought crucial rice cultivation knowledge. They built levees and managed tidal flow.
Planters built fortunes on enslaved labor. Rice became the most profitable export in colonial South Carolina.
Charleston's wealth, surpassing indigo and cotton, was built on the brutal labor of enslaved Africans.
Mortality rates on Carolina rice plantations were staggering. Malaria, exhaustion, and brutal labor killed them.
European colonial powers reshaped global rice trade for their economies, exporting even during famines. The Bengal famine killed millions, yet rice was actively exported to British markets for profit.
Rice, once a sustainer, was weaponized by colonial economics. Subsistence farms converted to export plantations. Dutch forced Javanese farmers to grow rice for export profit. Colonial trade was extraction, not partnership. Rice, once empire-building, now destroyed communities. The next chapter, modern science. Mid-20th century, surging global population, food crisis. Experts warned of mass famines. Asian rice yields were stagnant for centuries, traditional methods insufficient. An unlikely response emerged. In 1960, IRRI was founded. Its mission: produce more rice per plant on the same land. IRRI brought global scientists together. They crossed thousands of rice varieties, seeking a breakthrough.
In 1966, IRRI released IR8, a short, stocky plant, unlike traditional tall rice varieties.
Traditional rice fell over with fertilizer. IR8 stayed short, producing more grain per acre. IR8 doubled, even tripled yields, creating surplus for farmers. It was truly miracle rice. IR8 spread rapidly across Asia. Governments and aid supported adoption, leading to India's self-sufficiency.
India achieved self-sufficiency, but IR8 adoption wasn't seamless. Farmers resisted due to taste.
Farmers disliked IR8's taste and appearance, calling it ugly rice. IRRI bred improved IR8 versions with better flavor and cooking qualities. accelerating adoption further.
IR8 and crop improvements led to the Green Revolution. A pioneering figure in this field won the Nobel Peace Prize.
The Green Revolution, centered on rice, saved over 1 billion lives. Science fed a growing world.
Green Revolution wasn't a fairy tale. High-yield varieties required more inputs, leading to farmer inequality.
Rural inequality and environmental costs rose. Fertilizer runoff poisoned waterways, and monoculture spread disease. In 1970, grassy stunt virus devastated rice fields. IRRI bred resistance using preserved traditional varieties. Old varieties held genetic resistance, saving new ones. High yields erase rice's genetic diversity.
Rice remains Earth's most important food, feeding over 3.5 billion daily. China and India lead production. Asia produces 90% of global rice. The scale of cultivation is staggering.
Over 500 million tons of milled rice produced annually, almost all for human consumption.
Rice is incredibly diverse, with over 40,000 varieties used in countless global cuisines.
Rice dependence has costs. Paddles are major methane sources, a potent greenhouse gas.
Flooded paddies create anaerobic conditions, releasing methane. Rice cultivation accounts for 1.5% of global GHGs.
Methane emissions are enormous, like an industrialized country. Water scarcity is another major problem.
Rice is water-intensive, requiring thousands of liters per kilogram. Groundwater levels are dropping fast. Rivers feeding rice regions are drained by dams and industry. The Mekong is under pressure.
Climate change amplifies problems. Rising temperatures, especially at night, reduce rice yields.
Sea level rise and saltwater intrusion threaten coastal deltas, damaging rice paddies. Scientists develop drought and flood-tolerant rice varieties, using genes from traditional land races. Golden rice, a GM variety, produces beta-carotene, combating vitamin A deficiency.
Efforts to reduce rice farming's environmental footprint include alternate wetting and drying.
The story of rice is human civilization's story, from ancient origins to modern challenges.
From ancient banks to modern labs, rice has been at every turning point.
Rice fueled ambition, ingenuity, suffering, and survival throughout human history.
Every grain of rice embodies 9,000 years of human ambition, ingenuity, suffering, and survival. We rarely stop to think, reflect on rice's profound impact on our world.